Let us discuss the derivatives of exponential functions. Now, when it comes to derivatives of exponential functions, wherein we will consider two types of base also, wherein the base A, any value A, and base E. So for the first function of base A, which is expressed as y equal to a raised to u, now, the derivative of this function y with respect to x is now equal to a to the u, or a raised to u, then to be multiplied by a constant value of ln of a, and then to be multiplied by the derivative of that exponent, which is variable u with respect to x. Now, when it comes to base e as y equal to e raised to u, then the derivative of this function as derivative of y with respect to x is simply e raised to u to be multiplied by the derivative of u with respect to x. So as for our examples, we have these 6 numbers. So let us try the first example. For example number 1, we have that y is equal to e raised to 3x squared. So we can consider this as our u. And similar with our previous lesson, we can find the derivative of this exponent first. So if our u is 3x squared, then the derivative of this u with respect to x is just simply 6x by means of the power derivative. So bring down 2 times 3 and then less 1 from the exponent. So this is now 6x. And for the given function, the derivative of that function y with respect to x is now equal to, so this should be e raised to u times the derivative of u. So this is just simply e raised to 3x squared, and then to be multiplied by the derivative of the exponent u as 6x. Or we can also express our answer as derivative of y with respect to x is now equal to 6x times e raised to 3x squared. Now, for our next example, y is equal to 4 raised to 3x squared. So this time, if you're going to compare with number 1, this time the base is 4, which is a real number. Now, similarly, it is better to find the derivative of this exponent first, which can be our u, and this is equal to 3x squared. Then finding the derivative of this u by means of power derivative. Then the derivative of this u with respect to x is 6x. And for the derivative of this function y with respect to x is now equal to, this is a raised to u times the ln of a, and then to be multiplied by the derivative of u. So if we will follow that pattern, so this is now a to the u, so 4 raised to 3x squared times the ln of 4, and then times the derivative of u, which is 6x. Or we can also express our final answer as, we can start with the constant value. So this is 6 ln of 4, and then to be multiplied by x, and to be multiplied by 4 raised to 3x squared. So it's better to enclose with a pair of parentheses because this is understood cannot be multiplied with the 4x, as it is better as expressed in product form. So this is our derivative of y with respect to x. For number 3 example, our given is y equal to e raised to square root of 2x plus 1. So we can consider that our u, which is the exponent given, is square root of 2x plus 1. So similarly, it is better to determine the derivative of the u first, and then we'll just substitute to the given derivative of the function y. So by means of power derivative, this is understood raised to 1/2 also. Then the derivative of this u with respect to x is now bring down the exponent 1/2. And then the quantity should be 1/2 minus 1. And this is equal to negative 1/2. And then the derivative of this quantity as 2x plus 1. So the derivative is simply 2. And then simplifying the derivative of the u here, we can multiply the 1/2 and 2, and that will be 1. So for the derivative of u with respect to x, this is just simply 2x plus 1 raised to negative 1 half. And then, for our